an introduction to exponential functions. I'm going to go back and I'm going to talk about some parent functions. And so we've already done 3 different types of equations. We did a line, y equals x. That's the parent function of the linear function. And then we did the absolute function, and that was y equals absolute value of x, so that was the absolute value function. And then we just got done quadratics, and all quadratics look like this. And remember that when we had a line, if we wanted to move it up, we added 2. And if we wanted to move this guy up, we added 2. And if we wanted to move, oops, we didn't show you that one. We added 2. And if we wanted to move that guy up, the quadratic, we added 2. Okay, so we're going to erase that right now. And you know what a line looks like, and you know what an absolute value function looks like, and you know what a quadratic looks like. So our new one that we're going to do is we're going to do y equals 4 to the x, and this is called an exponential function. So I'm going to show you a couple of exponential functions and notice the characteristics and what actually happens to them. So, and it follows kind of the pattern here. So this is called exponential growth. It never touches the x-axis. If you zoomed in, it doesn't. And it starts here, and then all of a sudden it just grows pretty fast. It explodes. So I'm now going to do y equals -4 to the x. And just like when you put a leading negative in front of a quadratic, it reflected it. That negative, oh, sorry, that should have been an x. That also, the negative also reflects it. Okay? The other type is I'm going to do y equals 1/4. Oops. Having a hard time typing. To the x. And I'm going to compare, let's see if I can change the color of that guy. I can't. Okay, we're going to have to click them on and off. This is an exponential growth. This one is called an exponential decay. And so there's characteristics. So all exponential functions are in the form f of x equals b of x, where b is a number. Okay, and it cannot equal 1. An exponential function with the form f of x equals b to the x, b greater than 0, b cannot equal 1, has these characteristics. It's a one-to-one function, so it's telling you that it's an exponential function. It has a horizontal asymptote of y equals 0. The domain is anything, you can plug in anything, so all real numbers. The range is 0 to infinity. X-intercept, it will never touch the x-axis, so it doesn't have an x-intercept. The y-intercept is at 0, 1, because if you plug in a 0 for x, anything to the 0 power is 1. Exponential growth, or increasing, if this number right here, this b, is greater than 1, but it's an exponential decay if the b is less than 1. So let's go back to here and notice that here was an exponential growth, and here is an exponential decay. So it starts high and comes low. Both of them go through 0, 1. Okay, Now I'm going to do this graph, and I'm going to add another graph, and I'm going to do y equals 4 to the x, and I'm going to say, not there, but minus 2. And what happens is that is a transformation down 2. So instead of my y-intercept being at 1, it is now at -1. My asymptote is now at -1 also. Sorry, it's at -2. Okay, so it never will touch -2. So if I scroll in, it is at -2. Okay, this moves your asymptote down. Just like if I did plus 3, it moves the entire exponential growth equation up 3 units. I put a 0 in here. My asymptote is at 3, and my y-intercept is at 4. So you are going to be able to read these graphs as we continue on.